Good morning, friends. Today I will take a new topic, that is oxidation number. What is oxidation number? If we see in the case of the ionic compounds where reactions are the redox in nature, that is oxidation and the reduction both are going simultaneously in the same reaction. That is simply a transfer of the electrons from metals to the non-metals. But what happens in the case of the covalent bond, where sharing of the electron takes place? So for balancing the chemical equations, it was found that the oxidation number is very much important, and they defined oxidation number is the charge of an atom of an element. Listen, oxidation number is the charge of an atom of an element has in its ion. Is the charge of an atom of an element has in its ion when present in combined state with other atoms. Again listen, oxidation number is the number of the charge of an atom of an element has in its ion when present in combined state with other atoms. Or we say is a charge which an atom appears to have when all the other atoms are removed from its ion. So this oxidation number, it was found very important for the balancing of the reactions. Now there are so many conditions are there. I will explain you one by one. Now in the case of the molecules, when electrons share between the two like atoms and when the shared pair between the two unlike atoms. If we talk about the hydrogen, which is a molecule having two hydrogen atoms, that is when electrons share between the two like atoms. Now here we see two atoms of the hydrogen. By sharing the electron, it forms the molecules. It means one electron from each hydrogen atom. They are equally shared. It means one hydrogen atom has one electron. And you know, in the case of the hydrogen, one electron and the one proton in the nucleus. So we say that the oxygen in this case, hydrogen, is 0. That is one proton and the one electron. So in this case, when electrons share between the two like atoms, the oxidation number is always 0. Now second case, when shared pair between the two unlike atoms. For example, in the case of the HCl, here the point is that in the case of the HCl, chlorine is more electronegative in nature and the shared pair is shifted towards the chlorine, so it has one more electron. So in this case, oxidation number of chlorine become -1 and that of the hydrogen become +1. Again listen, when shared pair between the two unlike atoms, here point is very important is that which one is more electronegative in the compound. In the case of the HCl, it was found that chlorine is more electronegative. So the shared pair of the electron is shifted towards the chlorine and the oxidation number of the chlorine becomes -1 and of the hydrogen is +1. Now in the case of the organic chemistry, it is a fictitious charge. Okay. Now, third point is that oxidation number of an element in free state. Oxidation number of an element in free state is always 0. For example, helium, oxygen, hydrogen, and bromine which exist in free state. Now, in the case of the monoatomic oxidation number is same as that of the charge of the ion. Monoatomic oxidation number is same as the charge on ion. For example, potassium ion, calcium ion, aluminum ion. Here oxidation number of the potassium is 1, calcium is 2, and aluminum is 3. Now, in the case of the binary compounds, that is metals and the non-metals. Now, here we know that the metals, they give the electron to the non-metals. So, in binary compounds of metal and non-metal, oxidation number of metal is positive while that of the non-metal is negative. For example, in the case of the sodium chloride, sodium oxidation number is +1 while the oxidation number of the chlorine is -1. Now, in the case of the non-metallic compounds, with higher electronegative. See, in the case of the HCl, here hydrogen and the chlorine both are non-metallic in nature, then the higher the electronegative is the minus oxidation number. In the case of the HCl, chlorine is more electronegative, so its oxidation number is -1. But now if we take a case of the NH3, that is ammonia, here nitrogen is more electronegative than the hydrogen. Listen, in the case of the HCl, chlorine is more electronegative, while in the case of the ammonia, nitrogen is more electronegative than the hydrogen. Then the hydrogen, so it has oxidation number of the nitrogen become -3, while the oxidation number of the hydrogen is 1. So in the case of the ammonia, nitrogen is more electronegative than the hydrogen, so it has -3 oxidation number. Now in all hydrogen compounds, the oxidation number is always +1, except in the case of the metallic hydride. That is in the case of the calcium hydride, sodium hydride, lithium hydride, and the potassium hydride. Here the oxidation number of the hydrogen become -1. So in all hydrogen compounds of oxidation number is +1, but in metallic hydride it becomes the -1. Now oxidation number of the oxygen is always -2, but except peroxides and the superoxides. So today I discussed you oxidation number and its rules. Now in my next video I will explain some more rules and how to find out the oxidation number of an atom, an ion, or in a compound. Okay, so this is all about the oxidation number. If you like my videos, please share and subscribe. Thanks very much.